shiny like a metal? That's what we have to figure out. Because I can look at a mineral and I can see shine and light reflect off of it. And I used to say the reflectivity of it. But it's not reflection. Does it shine like a metal? That's one of the first questions you should ask when you go through a flow chart. Is it shiny like a metal? Is the luster? So you have two answers. What are your two answers? You have metallic or non-metallic. There are two answers for that. It's a yes-no proposition when you're talking about luster. Does it look like a metal? Does it not? So you're looking around in the minerals that you guys looked at. There's several of them that had a mineral shine, and Logan said their group even used the shininess of it a couple times to separate. Next up, color. Right?
Yes, sir.
Here's the problem with color. Color is just the color of the mineral, right? So it's very easy to talk about. It's the color. But it is unreliable. You can use it because it helps, but should you use it alone?
No.
No, because it's not going to give you enough information. The reason being, I can have quartz. Quartz can come purple, quartz can come pink, quartz can come white, quartz can come clear. That's 4 different colors of the same mineral. So if I use color alone, I'm not going to get the best results for my answers. So color is the color you see, but be careful, it's kind of like Wikipedia. It's unreliable.
Dang.
I don't know. Maybe. Streak. No, we're not running naked. Frank got a tank. Frank got a tank. Streak. What do you think? Anyone?
Like if it looks like it has layers, is that what you're talking about?
Nope.
No?
So there's a thing called a streak plate. So basically when you're finding the streak, the mineral property is the color of a residue left behind. So in other words, if you take that mineral and rub it across something, a line forms like you're writing with a pencil. The color of that line indicates or is used as a physical property. Some of you noticed that one of the minerals I gave you had a very distinctive streak. Which mineral do you think I'm referring to? The one that you guys identified as graphite. Graphite leaves a very distinctive gray streak by. Now, here's a little side note. Every one of you guys, I have no idea where it comes from, but everyone says that a mechanical pencil, they call them a lead pencil. Has anyone, you know exactly what I'm talking about. Mechanical pencils, everybody calls lead pencils. Am I correct by that? You've never heard someone call it a lead pencil?
They always say that lead's inside of it.
But it's not lead. So why are we calling it lead pencils?
Oh, he's angry.
Why you gotta be so hangry?
I'm not hangry. Because, you know what I had for lunch? Oatmeal. That's right. Oatmeal.
Oh, so you're definitely hangry. I know you are.
No. Anyway, so the color of the residue left behind. So graphite leaves a streak. There's another one that you have out there called hematite. If you would take it across porcelain, it leaves a red streak. There's actually a purple mineral that's floating around out there called fluorite. And if you take a streak, it's actually white. The color of the mineral is purple, but the streak is white. Why? Because the actual color that are stuck inside there to cause it to have that purple hue are so small, they're trace elements that are so small that when you streak it, the majority of it's white. That's one way you can use to identify minerals. Is luster enough to identify the mineral alone?
No.
No. Is color enough to identify the mineral alone? Is streak enough to identify the mineral alone?
Sometimes.
No. None of those are solo. You can't use any of those solo. The reason why we have all of the properties and talk about all the properties is because you got to use them together to identify the mineral. All right, so then we get to, I don't know, since I picked on them, we get to Corbin's favorite, cleavage. Anybody have a wild guess at what they think cleavage is? Sir, it is how it breaks, but it's specifically how it breaks. With cleavage, it breaks along clean, flat edges. So it breaks along smooth edges. When I broke, because you were watching this, Bailey and Mackenzie, when I broke the salt right in front of you guys, did it break into pretty much the same size, same shape? It did. It broke pretty much in a clean shape, right, into several different pieces, but all of them were pretty flat-edged shapes. That's because salt exhibits cleavage. Because of the chemical properties and the chemical combination of the way that salt is put and arranged, the way that those chemical bonds form, when you break salt, it breaks in a way that it makes a clean cut. It cleaves. Yeah? Okay. If it's not cleaning along smooth edges, what do you think it's going to be? It's going to be fracture. Because if it's clean, it's cleavage. If it breaks along rough, jagged edges, it's fracture, or it exhibits fracture. Right? So you have cleavage, you have fracture, you have color, you have luster, you have streak. There's one more that's highly important as well. And that's the hardness. And no, I'm not talking about how hard it feels when you hold on to it. This is how easily it gets scratched. So the easeability of scratch. Hardness is ranked on a 1 to 10 scale. I think most of you probably know. Do you know what's at the 10 scale?
Diamond.
Diamond is at the 10 side of the scale. Anybody know what's at the 1 scale? You know Earth science. How do you know this one? Did you have it before? Or are you a fan of rocks? Or? 8th grade, you remember it? A lot of this is a lot of it. Talc and diamond. So you have 1 to 10. Now, when we're testing it in class, I don't have talc and I don't have diamond. I'm never gonna give a class a diamond. Sorry, not gonna do it. But if I were to take one mineral and scratch it against another mineral, that's how we start to compare the hardness. So if one scratches the other, which one's harder? The one that does the scratching or the one that gets scratched? The one that does the scratching is going to be harder than the one that gets scratched. So there's 3 things and 3 objects that we use in class to test it. One is your fingernail. So we can break them down into minerals that are weaker than your fingernail or stronger than your fingernail. A fingernail has a hardness on a scale of about 2.5. The other test that we do in class is a penny. So you'll take your mineral, scratch it across the penny. If it leaves a scratch on the penny, is it harder than the penny or softer than the penny?
Harder.
It's harder, right? So we can break that up into harder than the penny, softer than the penny. And a penny has a hardness of about 3.5. We skip the 4s, and then we go to 5, 5.5 or 6. It depends upon what book you see, and that's glass. So you always hear the story to the guy, like girls. They tell girls to test the diamonds, right? Or like you see people testing diamonds and they take it and they scratch it across a mirror. Why are they scratching across the mirror? Because that's glass. If it's diamond, what's going to happen to the mirror?
It's gonna get scratched.
It's going to get scratched. So girls, if you don't trust your man, when he's not looking, scratch it across the window. If it leaves a mark, is it more likely a diamond? If it doesn't leave a mark, yeah, Corbin, you need to step up your game a little bit and actually buy a diamond. Justin, what's your question?
What's the hardest cubic zirconia?
Cubic zirconia, to my knowledge, is under 5. I just don't know exactly where it's at. That's the one that doesn't leave. It wouldn't leave a streak. Nope. So those are 6 that we'll talk about today, and we'll use those coming up.